Hi friends, this video is completely about class 8th maths rational numbers. So this video I'll explain you complete information ICSE syllabus of class 8th maths rational numbers topic. So before that I'll show you one website here. You can see it down also. So in this website foundation4iit.com you'll find out class 6th to 12th all the subjects chapter wise question bank and topic wise test papers, subject wise model papers including IIT, JEE, MCET materials also freely you can download and you can go through. So this channel is completely educational videos only will upload. So please subscribe the channel and follow the content. So if you subscribe the channel directly, you'll receive the videos whichever you are giving from the educational videos from this site as well as from this channel. Fine. Now we'll start the rational numbers topic. In earlier classes, we have studied at natural numbers, whole numbers, integers, and fractions, right? Now we will review these numbers and we'll study the rational numbers. So once we review all the topics which are the number systems which we studied in previous class, that is class 8th and class 7th or 6th. Natural numbers. So counting numbers are known as natural numbers because whenever we count anything, we'll count from 1. So we'll never count from 0. So if the number of students in a class, we'll start with 1 only. 1, 2, so on. So these are all nothing but counting numbers as well as natural numbers will denote with capital N. Whole numbers. Next number system is whole numbers. This already studied earlier classes. Once again we'll revise this. Every natural number as well as 0 is a whole number. So whole number will denote with capital W. That means every natural number along with 0. That is 0, 1, 2, 3 up to infinity. Now these are the whole numbers. Next, so in this both we have positive numbers, integers. Now in integers, every whole number and the negative of every natural number is an integer. So every whole number and negative of natural number. That means we'll denote this integers with z. Some books you can see the I also. So every whole number, there is 0, 1, 2, 3 and so on, and every negative natural number, that is 1 is a natural number, so -1, -2, -3 and so on, this negative side. So the other value will be decrease when you come to left. So in integers itself we will see negative integers, non-negative integers. So in this if you observe, -1, -2, -3 so on, these are all negative integers, right? And 0, 1, 2 from 0 onwards, these are all the non-negative integers. At the same time 0, -1 is nothing but also non-positive integers which are not negative, they are positive, and which are not positive non-positive also. Next, fractions. So the numbers of the form a by b, in a by b form, The condition is where a and b are the natural numbers are called fractions. A comma b, they belongs to natural number. That means there is a belongs symbol. A and b are both should be from natural numbers. So for example, 3 by 4, 18 by 19, 2 by 3. So these are all nothing but fractions. They are in a by b form. That is numerator by a denominator. This is nothing but fractions. So these are the topics you have studied already. Now we will start with our topic, rational numbers. So how to make the rational numbers now? How to identify, then how to, yeah. So we'll check it first. In rational numbers, the numbers which can be expressed in the form of p by q. So this is a little different from fractions to rational numbers. So I'll give clarity about that. The number which can be expressed in the form of p by q, but where p and q are integers here. P comma q are integers, but q should not equal to 0 because q is the denominator. Q is not equal to 0, all called rational numbers. For example, if you take, that means every fraction is also a rational number. But apart from that, if you take some integers, minus 3 by 2, 2 by 3, minus 1 by 2. So these are all the examples of rational numbers. So they are in p by q form, where p and q are the integers. And main condition is q is not equal to 0. So negative as well as positive all come under rational numbers. Some more examples I'll give you. 7 by 4. These are all nothing but positive. 23 by 18. 17 by 19. So on. Then if you see the negatives also, minus 10 by 9. 1 by minus 2. So negative may be numerator or denominator. So these are all the rational numbers. So let us see some more points from the rational numbers. For example, 0 can be written as 0 by 1 because 0 also rational numbers. You can write 0 by 1. 0 by 1 is nothing but 0. So 0 also is a rational number. Since division by 0 is not permissible, so any number divided by 0 is not defined. Now 0 is rational number. We can write, for example, if I write 1 by 0, 2 by 0, minus 3 by 0. So these are all not defined because denominator, because the condition is q is not equal to 0. Right? Here q is not equal to 0 because denominator should not be 0. Now they are not the rational numbers. So every fraction is also rational number. That is also we can make it one sentence. Every fraction is a rational number. But every rational is need not be fraction. Now from this same thing, some more points from the rational numbers. Positive rationals and negative rationals also we'll see now. positive rationals, negative rationals. So first of all, if you see the positive rational, a rational number is said to be a positive if its numerator and denominator either both positive or both negative, because finally we need output should be positive. So if I write minus 3 by minus 2 example, because minus 3 by minus 2 is nothing but again 3 by 2, 3 by 2, minus 4 by minus 5, that is nothing but 4 by 5. So this is equal to 4 by 5. So these are all the positive rationals. Maybe final result is positive or not. Minus 3 by minus 2 is also positive rational. Minus 4 by minus 5 also positive rational, because final result should be positive. Now negative rational is any one of them. If its numerator and denominator are opposite sign, then we can say a negative rational. Opposite sign, numerator and denominator. For example, numerator is minus 3, denominator is plus 4. Or numerator is plus 2, denominator is minus 5. So numerator and denominator, if both are opposite sign, then they are said to be negative rationals. So these are the brief information about rational numbers. Now we'll see some important properties of rational numbers. Important properties of rational numbers. So we'll see the properties of rational numbers now. So there are three important properties are there. First property is, if p by q is a rational number and m is a non-zero integer, then p by q is equals to p into m by q into m. Okay, I'll write here. If p by q is a rational number, if p by q is a rational number and m is a non-zero, for example m is any number and it is non-zero integer, m is non-zero integer, then the first property we can write that p by q is equals to p into m by and q into m. So now these both are equal. P by q is equals to p into m by q into m. Okay, for example, if you take now minus 2 by 3, this is the rational number, so it is a negative rational number. Okay, take some other number 4. Now this is equals to minus 2 by 3 minus 2 into 4 by 3 into 4. Now this is exactly equal. Any number you can multiply, or this is equals to minus 2 by 3 into 6 by into 6. So final result is same. Minus 2 by 3 is equals to minus 2 into 4 by 3 into 4 otherwise minus 2 into 6 by 3 into 6, it's equal. For example, you can simplify. Now minus 2 by 3, this is minus 2 into 4 minus 8 by 12. Okay, that is also equals to minus 12 by 18. Now these three rational numbers are equal. So observe here, this is equal to this and this is equal to this. So minus 2 by 3 is equals to minus 8 by 12 and this is equals to minus 12 by 18. So such rational numbers are called equivalent rational numbers. So these are all the equivalent rational numbers. Now let us see the property 2. So second property in rational numbers. Similarly, first property we did multiplication, right? Numerator and denominator. Now this is just division. If p by q is a rational number, if p by q is rational number and m is a common divisor, for example m is common divisor of p and q, therefore we can write p by q is equals to p divided by m by q divided by m. So if it is a common divisor, means you can divisible if it is divisible in the p and q with m. So I'll give you an examples, understand clearly. Okay, let us take 24 by 48 because it's both are even numbers, we can do division. Now this is number, this is equals to the same number, we should do division both, right? 24 by 48. Now both are, if we take 2, 2 is a divisor of both 24 and 48. So not only 2, we can do division with 3 also. 24 divided by 3 by 48 divided by 3. We take some more example. 24 divided by 12 by same 48 divided by 12. Now these are all equal. Let us simplify. 24 by 48. 24 by 2 is 12. 48 by 2 is 24. Now 24 by 3. 8. 48 by 3 is 16. Now this is 2, 4. Yeah. So these are all the equivalent fractions, right? 24 by 48, 12 by 24, 8 by 16 and 2 by 4. These are all the equivalent fractions. One more property. Let's see the last property in this. So third property, let a by b and c by d are two rational numbers. I'm taking 2 now. Let a by b and some one more rational number is c by d. Then if a by b is equal to c by d, if two rational numbers are equal, then a into d, this is nothing but cross multiplication, a into d is equals to b into c. Now this is equal. Now if you take this is a b, so this is also another property in rational numbers. If a by b is equal to c by d, That implies A into D is equal to B into C. So just a cross multiplication we did. A into D. That is again equal C into B. So using these three properties we can write equivalent fractions. So in exercise they will give some fractions. We need to write equivalent fractions. So let us see a few examples. So to write equivalent fractions, we'll use the first and second properties. Example. For example, write 4 rational numbers equivalent to 2 by 5. They gave 2 by 5. Write 3 equivalent fractions. So equivalent rational numbers. So 3 equivalent rational numbers you need to write for 2 by 5. Now take 2 by 5. Because according to the first property we can multiply any number numerator and denominator. 2 by 5 into 3 into 3. Same number should multiply for numerator as well as denominator. Or same 2 by 5 into 2 into 2. I took 2 now. They are asking 3 equivalent. Okay, 3 we can take. Now 2 by 5. So into 4 and into 4. Same number we need to multiply for numerator and denominator. Now this if you simplify you will get the answer. That means 2 by 5. That is equals to, just simplify, 2 4s 6 by 15, 2 2s again 4 by 10. These are equivalent fractions. 8 by 20. So 3 equivalent rational numbers for 2 by 5 are 6 by 15 comma 4 by 10 comma 8 by 20. So these are all the equivalent rational numbers. Now let us see the standard form of the rational number. Tell you know here. There are some standard form of rational numbers. Actually, how we need to write the rational number on which form? That means nothing but to actually simplify the rational number. For example, if you take 48 by minus 20. Now this is the rational number. Now what is the standard form? Now standard form of this rational number. So first of all, a rational number p by q is said to be in standard form if p and q are integers having no common divisors other than 1. So we should not take any other divisors except 1. 48 and 20 are we can divide with 2 table. So no common divisors. Now 48 by minus 20. First minus 1 by minus 1. You multiply. Then it will be minus 48 by plus 20. Again minus 48 by 20. So we can do divide 4 and 4 both. Then this becomes minus 12 by 5 because 20 by 4 is 5. Right now for 12 and 5 there is no any common factors or common divisors. Therefore minus 12 by 5 is the standard form. Because we should not simplify further. If you could not simplify further, then that is the standard form. Now let us go to one more topic. Comparison of rational numbers. How we need to compare the rational numbers. Comparison of rational numbers. Comparison of rational numbers. So comparison nothing but which rational number is big or which is the small, which is how much time it's more than the other number. So there is nothing but comparison. If we know the numbers of natural numbers or whole numbers or integers, we know how to compare. For example, if we take 5 and 12, we know 5 is the less than 12 because 5 is less than 12. If we take minus 5 and minus 12, then minus 12 only less. That means minus 5 is greater than minus 12. 5 and minus 12. No, 5 is greater than. Minus 5 and 12. Minus 5 is less. So these are the less than symbol, greater than symbol. This is greater than symbol. This is less than symbol. And this greater than symbol. This is less than symbol. So minus 5 is less than 12. So we know how to compare the numbers when the integers are given. Now this topic will see comparison of rational numbers. So let us follow some few steps. So which are the steps we need to follow? I'll explain you first. So step 1 is, so actually they will give some rational numbers. We need to see which is less or which is more. So it's not by seeing directly rational numbers we can't say which is bigger or which is small. For example, 2 by 3, 17 by 20. So like this comparison we cannot know directly by seeing, because 2 by 3 and this 17 by 20. We can't guess directly by seeing the rational numbers which is small or which is the big. That's why we need to use some basic properties or some steps to see how to compare the rational numbers. So first step is express each of the given rational numbers into form of having positive denominators. Okay, for example, we'll take one simple question. Let me take one question and we'll see the steps. Minus 5 by comma 24 9 by minus 24 minus 3 by 4 and 7 by 16. So these are the four numbers, four rational numbers. Now in these four rational numbers I need to compare, or I should write, for example, ascending order. That means which is the smallest and next to small, like that, then which is the bigger. So I need to make them into ascending order. So we need to writing ascending order means we should know first of all what is the small number and what is the bigger number and what is the order. Now let us see. So this is minus 24. So if the numbers are given like this, the first step, express each of the given rational numbers into the form of having positive denominators. First step is we have to convert into positive denominators. So all the denominators should be positive. So first number is minus 5 by 24 and second is 9 by minus 24. That means multiply with minus both. that we can write minus 9 by plus 24, because 9 by minus 24 or minus 9 by 24 is same. Second is minus 3 by 4 and 7 by 16. That is convert into positive denominators first. Now step 2, find the LCM of these positive denominators. Find LCM of all you studied LCM in earlier classes. Find LCM of these positive denominators. Okay, let us find the LCM of these positive denominators. That is 24, 24, 4 and 16. So I'm doing LCM now. So I can take directly 4 table 6, 6, 1, 4. So I already studied. So I'm going fast. Now 2 table 3, 3, 1, 2. Again we can take a 3 table 1, 1, 2 asterisk. Then let us take next last step is 2. Now this all is already 1, 2 ones are 2. This we need to multiply. Now 4 into 2 into 3 into 2. So 4 2 is 8, 8 3 are 24, 24 2 is 48. Okay, 48 is a LCM now. Now this is the fractions, rational numbers. Finally got LCM is 48. So step 2 is we need to find the LCM of these positive denominators. We found the LCM is 48. Now express each of the rational numbers in step 1 to equivalent rational numbers. So we need to convert them equivalent rational numbers. So next step, express equivalent rational numbers. So let me express this all in equivalent rational numbers with the denominator should be 48. Now first one is minus 5 by 24, right? Minus 5 by 24. So we need equivalent rational number, but denominators of all the rational numbers should be 48 because LCM is 48. Now 24. So into 2 and 2 because 24 2 is a 48. Next one, if you see this minus 9 by 24. Minus 9 by 24. Now denominator is 24, so 2 and 2. Next is minus 3 by 4. And what we need to multiply? You can just check it now. Next is 7 by 16. 7 by 16. So what we need to multiply to get denominator should be 48. Yeah, I can check it. 4 table 48. 12. Same 12 you should keep here. And 16 table 16. How much 3 is on? And 3 also keep here. So this is expressing equivalent rational numbers. Then you can simplify. Now if you simplify this all, minus 5 into 2. Minus 10 by 48. Minus 18 by 48. Just I am simplifying now. 12 3 is minus 3. minus 36 by 48. 7 3 is 21 by 48. So once if you make the denominator same, that means if you convert into equivalent rational numbers with same denominator, then we can directly, by verifying the numerator, we can compare them easily. Then last step, arrange the rational numbers in increasing or decreasing order. Now we need to make increasing or decreasing according to the numerator. So write increasing order by comparing the numerators, because denominator is fixed, denominator is same all. Now according to that, the first one is minus 10. If you observe here, minus 10, minus 18, minus 36 and 21. So smallest one is minus 36. Therefore increasing order. So minus 36 by 48, and next is minus 18 by 48, next is minus 10 by 48, and 21 by 48. Now this is a we converted, then you can write the original value of which is belongs to. Now first smallest value is minus 36 by 48, but originally this is not the given question number. Minus 36 by 48 means if you take 2 up, that is minus 3 by 4. Now this is the smallest one. So as according to that, if you make in order, increasing order, minus 3 by 4 is less. Next is minus 18 by 48, there is a minus 18. Next is minus 18 by 48, second place. There is minus 9 by, so you can make it, so you can make it order, minus 9 by 24. Now this is minus 5 by 12, and finally 21 by 48 is nothing but 7 by 60. Now these are the steps we need to follow to comparison of rational numbers. So only thing is we need to arrange the denominators to equivalent rational numbers, and there is nothing but we need to take a LCM and should make LCM should be equal to for all the denominators. So not only 4, any 2 or 3, more than 2, if they will be also same procedure. If they'll give 2 rational numbers and ask to compare also, then we can take the two rational numbers denominators and we'll find out the LCM. Just we need to simplify this. So next we will see a representation of rational numbers on number line. So how we need to represent rational numbers on number line. Now let us see representation of rational numbers on number line. Okay, let us see now representation of rational numbers on number line. So how we need to represent the rational numbers on number line. So let us see now. So we'll take one example first and let us see how to represent this all in number line. So what are the steps we need to follow first? So every rational number can be represented by some point on line. So first you need to draw a line, mark a point O. On it represent the integer 0, set of equal distance on both sides. So every rational number also we can represent on a number line. Draw a line, first step. Then on some point just to mark a point O. So this I am marking O. Now take equal distance and set off the integers of the points on both sides. 1, 2. So left side is same distance, -1, -2. So this is nothing but representing, actually preparing number line. Now according to our given question we need to represent. So there are three type of rational numbers. There is proper fraction, improper and mixed. Okay, first let us see if they'll give proper fraction means a proper rational number. How do we can represent? Maybe both are negative or positives also, we can do the same procedure according to the given line. Now let us consider the rational number 3 by 5. I'm taking 3 by 5. So 3 by 5 is a proper fraction. Actually every proper fractions are less than 1, and this is a positive proper fraction, that means more than 0. So this should be between 0 and 1 only. Okay, 3 by 5 is a proper fraction and which is a positive. So proper fractions are less than 1, and because if it is a positive it must be greater than 0. So it should be in between these two, between 0 and 1. Now first step is just check whatever denominator here. Denominator is 5. If denominator is 5, make 5 equal parts or divide the unit length between 0 and 1 into 5 equal parts. 5 equal parts you have to make between 0 and 1. So I am taking 5 equal parts. So 1, 2, 3. So parts should be 5 exactly, not lines. So 0, this is starting 0 and this one part, second, third, fourth, 5. 5 parts. Now this is first part, second, third, fourth and fifth part. Fine. So just we need to represent, now this is 3 by 5 means third part out of 5. So numerator is 3 now. So because of the numerator is 3, you can take the third part. Now 1, 2, 3. Now this is 3 by 5 because third part itself. So just two steps. First prepare the line, then according to the denominator take that many parts, and which is the numerator, particular part from the 0 is the number position on the number line of this rational number, that is 3 by 5. So for example they asked 1 by 5. So 1 by 5 means this is also proper fraction. Now 5 parts in this first part. Now this only 1 by 5. So this next one is 2 by 5, 3 by 5, next is 4 by 5, this is 5 by 5. So 5 by 5 is nothing but 1. That's what we can make it as 1. Now this is positive proper fraction. So in this we have improper fractions. If it is improper fractions, we can convert into mixed fraction, then we need to represent on a number line. Okay, second part we'll see if it is improper fraction, now we need to represent on the number line. Let us take 13 by 4. I'm taking the number is 13 by 4. So 13 by 4, how we need to represent on a number line. So take the number line. Mark any point 0 and 1. Okay, 13 by 4 is, if you convert into mixed fraction, that is 3 1 by 4. 3 1 by 4, because you can do division. 13 divided by 4. 4 3 is 12, remainder is 1. Now this is the order, this is the line. 3 next to 1 by 4. That means it's more than 3, less than 4. Right? So you can take 3 and 4 some more big size, big place. So I take 0 little this side. So 0, 1, 2, 3 and 4. So your number is 3 1 by 4. That means this is 3 point something. That means it's more than 3 and it should be less than 4. Now don't see the 3 now. So remaining part is 1 by 4. So in 1 by 4 denominator is 4. So because of denominator is 4 and it will come after 3, make into 4 equal parts after 3. Make 4 equal parts between 3 and 4. So 1, 2, 3, 4. So 4 equal parts we need to make. 1, 2, 3 and 4. Now to represent this 3 1 by 4 on number line, after 3 we made 4 parts. So first part is the 3 1 by 4. That is first part itself. This is 3 1 by 4. Because next is 3 2 by 4. Next is 3 3 by 4. Next is 3 4 by 4. That is 4. Let us take 2 1 by 3. This example. Then that means it's more than 2 and less than 3. And denominator is 3. Therefore, between 2 and 3 we should make 3 equal parts. Because denominator is 3. Now 1, 2, 3. Between 2 and 3. So if you represent 2 1 by 3, it's after 2. 1 by 3 means first part. Now this is 2 1 by 3. This is the way, if any improper fraction is given, convert into mixed fraction and they can represent on number line. Mixed fraction, if they'll give in question, directly we can make it. And most important thing is the last one is if they'll give negative numbers, negative fractions and negative rational numbers, they'll give how to do, we'll see. Just you will do negative side, means of below 0 it is. So let us take, if it is negatives, for example taking minus 9 by 7 or minus 1 by 4. Now these are the numbers I need to represent on number line. So make number line. Since both are negatives, I am taking negative side little more value. Zero, that is 1, minus 1, minus 2, minus 3 and so on. So minus 9 by 7. We can, if we convert into mixed fraction, this minus 1 2 by 7 minus 1 2 by 7, because 7 1 7 plus 2 9. Now we can do division. Minus 1 2 by 7. The first one minus 1 and some extra is there. That means it will go towards the minus 2. So it is greater than, less than minus 1 and greater than minus 2. So in between minus 1 minus 2. Same procedure. Your denominator is 7. So we should make 7 equal parts. So let us take 7 equal parts. Minus 1 and minus 2. 7 parts we should make. So 1 2 3 4 7. Yeah, 7 parts I made. Now we should actually, positive means from 0 to right side will take. Now negative means 0 to left. Now after minus 1 we should come towards left side. That means left side second place, because 2 by 7. So in 7 parts, the second part from the left, we should come to the left side. Now 2 by 7. That is, this is first place and second. Now this is minus 1 2 by 7. So next is minus 1 3 by 7. Next is minus 1 4 by 7. Finally, like minus 2 will come. Okay, this is 1. Next we have to see minus 1 by 4. Minus 1 by 4 is the proper and between 0 and minus 1. That means 4 parts. So let us make the 4 equal parts. 4 parts I made. In that first part itself, from this, because from the 0 onwards you have to come from left. Now this is minus 1 by 4. So next place is minus 2 by 4, minus 3 by 4, minus 4 by 4. So this minus 4 by 4 means minus 1. Fine. If it is a positive, we'll take the positive side. Negative means you'll take the left side. This is negative side. So this is the way we can represent rational numbers on the number line. So addition of rational numbers. So now we'll continue this with rational numbers, how we need to add. So most important rule we need to follow for this. In order to add two rational numbers, we first convert each of them into rational numbers with the positive denominators. We need to convert, denominators must be positive. For example, if the question is given minus 3 by 5 and 3 by minus 5. Okay, I'm taking some 15. Minus 3 by 5 and 3 by minus 15. So here denominator is plus 5, but your denominator is negative 15, right? So we need to convert, if any fraction is negative denominator, we have to convert into positive. That means this we can write minus 3 by 15, because if you multiply with minus numerator and denominator, it will convert into minus 3 by 15. So minus 3 by 5 will take, minus 3 by 15 will take, and we need to add. So important rule is, first we need to convert every rational number with positive denominators. So let us see the two cases in addition of rational numbers. First case is when the given rational number have the same denominator. If the given question itself, the rational numbers have the same denominator. So rational numbers have the same denominator. Fine. Then sum of the two rational numbers of the form Then how if the denominators are same, they are in this form, right? Like m by q and some n by q, because denominators are same. Then if you want to add this both, m by q plus n by q, just will add denominators as it is, we just will add the only numerators. So m plus n by q, if the condition is if the denominators are same of the rational numbers. So let us take example also. For example, 3 by 17 comma minus 2 by 17. Then we need to add this both. So 3 by 17 plus minus 2 by 17. So here denominators are same. Therefore 17 is denominator. 3 plus and minus 2. That is 3 minus 2 by 17. So 1 by 17. So we already studied earlier classes how we need to add the positive negative numbers. So 3 minus 2 is 1 by 17. No, this is the condition. If you take one more example also similar. Now 2 by 5, 3 by 5, 1 by 5. So if you want to add this, we'll take only denominator of all, because denominator is same in three rational numbers. So if you want to add, just you need to add the numerators. 2 plus 3 plus 1, that is 6 by 5. Now this is the case 1. That means if the denominators are same, then how we need to add the rational numbers. For example, case 2, if you observe, most of the problems will be in case 2. We'll see, we'll understand clearly how to solve when the given rational numbers have unequal denominators. When the given rational numbers have unequal. So when unequal denominators, then how we need to add. So in this case, we find the LCM of the denominators and express each of the given rational numbers into equivalent rational numbers having the LCM of the as the denominator. So equivalent rational numbers we are discussed in previous topic, right? So okay, let us with example I'll explain directly. Minus 5 by 12 and 4 by minus 9. Now add this both, because your denominators are unequal. Now here is minus 12 and this is minus 9. So first step is we have to write denominator should be positive. That means minus 5 by 12 and this is minus 4 by plus 9. So minus, you just shift to numerator. Okay, then first condition is here is 12 and here is 9. So first we should take the denominators LCM. 12 comma 9. So LCM of 12 comma 9. 12 and 9 LCM, if you take 3 table, 3 4 is a 12, 3 3 is a 9. So 4 and 3 no common factors. So once you take 4, once you take 3. So 3 4 is a 12, 12 3 is a 36. So LCM is 36 now. Just multiply 3 4 3. So we should make denominators must be as 36 for this both fractions. So minus 5 by 12 and minus 4 by 9 is the given conditions, given rational numbers. So what we need to multiply? Into. So with the same number you should multiply separately. We should make 36. Now if you want 36 denominator, I should keep here 3, because 12 3 is 36. Same 3 keep here. So case 1 is they only gave denominators are same, so I just did only for numerators. Now case 2 denominators are not same, so we should convert them it as same. That means only with the help of taking LCM. Right? Now here 9, that is 9 fours are 36. So same 4 you keep here because you have see the properties in rational numbers. Now just to simplify this, minus 5 into 3. So minus 15 by 36 and minus 16 by also 36. Just we need to add this sum now, because sum, that is minus 15 plus minus 16 by 36, because denominator is same now. So minus 15 plus minus 16 is minus 31 by 36. So after doing, if it is possible, we can simplify, otherwise we can leave that. Minus 31 by 36 is the sum of these numbers. Let me explain one more question, one more sum. Then we will see properties of the addition of rational numbers. After an explanation, one more problem. Find the sum of minus 11 by 15 plus 7 by 12. So this answer we need to find out. So LCM of 15 and 12. LCM of, because denominators are not same, so they're unequal denominators. So we should find the LCM of 15 and 12. So 15 comma 12 LCM, if you take 3 table, that is 15 and 12. 3 5s and 3 4s. So we can multiply this all. So 3 into 5 into 4. 60 is LCM. Now we should make it as 60. So direct LCM of 12 and 15 is 60. So there is direct method, I'll tell you. Now take the 60 and keep a line. Instead of making individually, here denominator is 15. So in 15 table, we need to check 60 because we need to convert this denominator should be 60. That means 15 into dash is 60. That is 15 into 4. Right? Now take the same 4 and multiply numerator also, because same number should multiply and above and below. So for example, because this into 4 means same, this also should be 4 only. Now 12 into 60 means 12 into 5. So same 5 we should do for this also. So direct step I am making, that's right. Minus 11 into 4 plus next year's 12 table 60 5s are. So 5 into 7, that is 7 into 5. So this is, instead of for taking extra one more step, we can do directly. Now minus 11 into 4 is minus 44. 7 5 is a 35 by 60. So minus 44 plus 35, that is minus 9, because 44 is the bigger number. Minus 9 by 60. This we can cut into simplest form. If you're familiar with cancellations, you can do directly. You can do 3 table, I can cancel. 3 3s are 3 20s are. So minus 3 by 20 is the value or sum of minus 11 by 15 and 7 by 12. Right? So this is the addition of rational numbers. So I'll explain you now some properties of addition of rational numbers. So what are the properties? Let us see. Properties of addition of rational numbers. Addition of rational numbers. So on based of addition of rational numbers, let us see what are the properties are available. So generally we study some properties like closure property, commutative, associative, and additive identity. So it's existence of additive identity, existence of additive inverse. So let us see briefly everything now. So property wise I'll explain. First property is, let us see closure property on rational numbers. So with respect to addition. So briefly I'll tell you. The sum of two rational numbers is also rational number. There is nothing but closure property, because sum of two rational numbers, if any two rational numbers if I add, then that result also is a rational numbers. That means if a by b comma c by d are two rational numbers, then a by b plus c by d, this is also a rational number. There is nothing but closure property. Similarly we have one more is commutative law. So commutative law is, if a by b and c by d are any two rational numbers, so a by b and c by d, if these two are any two rational numbers, then commutative law is nothing but, we can, a by b plus c by d is also equals to c by d plus a by b. So if you take reverse, means just both in different positions also, if you add also, you get same. So like how numbers, natural numbers are exist commutative law, similarly rational numbers also will follow the commutative law, because a by b plus c by d is equal to c by d plus a by b. You can take one example also, you can verify any number. For example, if I take 5 by 9 plus minus 7 by 15, this also sum, and minus 7 by 15 plus 5 by 9 also will come same solution. That is nothing but commutative law. So property 3 is associative law, also it exists. Associative. So briefly I'll explain, not going too deep, because I already studied this laws. If a by b, associative law is, we need to take three rational numbers. If a by b, and take some c by d and e by f, these are the three rational numbers. Then associative law says a by b plus c by d, add this both and add to e by f. This result is also equals to a by b plus of this c by d plus e by f. So next is second, third and add, then followed by add to the first two rational number, even though it gives the same result. So this is nothing but associative law, because the addition of rational numbers, they follow these all the properties. Next is existence of additive identity. So we know additive identity and additive inverse. Generally additive identity in natural numbers is 0. Right? So same 0 also is additive in identity in rational numbers. That is additive identity. So in additive identity, so here 0 is the additive identity, because if you add any number, for example a by b plus 0, this also 0 plus a by b, even though we'll get same rational number a by b only. Okay. You can take example. For example, if you take, because 0 you're adding, 2 by 3 plus 0 is nothing but 2 by 3 only. Otherwise 0 plus 2 by 3 also is again 2 by 3. So this is additive identity. So 0 is the additive entity. Now additive inverse. For every rational number a by b, there exists another rational number minus a by b. Is additive inverse, because we should get additive identity if you add. Additive inverse this. For example, a by b is a rational number, then additive inverse is minus a by b. Okay, this is additive inverse for this, or reverse. If a by b is a rational number, then minus a by b is additive inverse. Because this both, if I'll add, I'll get 0. That's what their additive inverse. So the additive inverse of rational number is 0 itself. So if we take any 0, because 0 is also a rational number, right? So 0 additive inverse also is 0 only, because 0 plus is 0, 0 will come. So these are the properties which are related to the addition of rational numbers. Right? Now let us see the subtraction of rational numbers now. Subtraction of rational numbers. So how we need to subtract and what is the rule? So just we'll see. Yeah. So let us see this subtraction of rational numbers. So what is the rule to subtract any two rational numbers? So first we will see some rule. Rule is nothing but to subtract one rational number from the other, we take the additive inverse of the rational numbers to be subtracted and add to it, to the other rational number. So subtraction is nothing but addition only, but we should take additive inverse of another number. Okay, I'll explain it briefly. For example, a by b and c by d. Then we need to subtract c by d from a by b. So what will take a by b as is? So what we need to add? We need to add additive inverse of c by d. Additive inverse of c by d is minus c by d. So minus c by d, if you add to a by b, then that is nothing but subtraction. Because additive inverse of c by d is minus c by d. That is a by b minus c by d, we can write. I'll explain you some examples. So let's take one question. Subtract minus 5 by 6 from minus 3 by 4. So from minus 3 by 4, that means my okay, we have to subtract minus 5 by 6 only. So according to the rule, so as per the rule, what should take? Minus 3 by 4, because this is from, and we have to subtract minus 5 by 6. That means I should add additive inverse of minus 5 by 6. Additive inverse of minus 5 by 6. So additive inverse of minus 5 by 6 is plus 5 by 6. That is minus 3 by 4 plus additive inverse of minus 5 by 6 is plus 5 by 6. So finally minus 3 by 4 plus 5 by 6. So 4 comma 6 LCM is 12, because you know how to find LCM. So in 4 table, So that denominators we must make it to LCM. So in 4 table when 12, because 4 into dash is 12, because 4 into 3, same 3 we should multiply for even numerator also. That's what 3 into minus 3 plus next to 6. In 6 table 12 is 2 times 2 is, so 2 into same fraction numerator. So minus 9 plus 2 5 is a 10 by 12. Minus 9 plus 10 is 1 by 12. So 1 by 12 is the answer for this. So this is the way we can do subtractions. I'll tell you one more simple question. One more problem, let us see. So example is like this. What number, for example, in generally natural numbers we'll see. Now for 5, and what number I need to add to 5 to get 8. So what number we need to add to 5 to get 8? That is 3. So how do you know 3 means? From 8 directly this 5 subtract, because 8 minus 5 is equal to 3. Okay, what we need to get from what number we should add means that only subtract from the result. So this one we'll see here. What number should be added here? Here is added. What number should be added to minus 7 by 8? Yeah, to get 4 by 9. So what number we need to add to minus 7 by 8 to get 4 by 9? So what number we should add means take some x it is. So the required number is x. Then solution is minus 7 by 8 plus some x we need to add to get 4 by 9. So these we need to simplify. So we need to find out the x value finally. So x is equals to 4 by 9. So minus 7 by 8 is, if we interchange, it is nothing but additive inverse. That is plus 7 by 8. Because here negative 7 by 8. When you take another side, it will become additive inverse. That is plus 7 by 8. Then the remaining is a normal procedure. 9 and 8 LCM is 72. In 9 table 72 is 8 0. Then 8 into 4. So 32 plus, here in 8 table 72 is 9 0. 9 into 7 is 63. Then that is 95 by 72. Now this is the required number. So this, if you add 95 by 72 for that given question, then we'll get 4 by 9. Similarly, they ask what we need to subtract to get. This is what we need to add. So we'll get some questions what we need to subtract also. Okay, let us take one more question what we need to subtract type. What should be subtract from? So here from is minus 5 by 7 to get minus 1. So what we need to subtract? So what we are subtract means take some x. Now minus 5 by 7, what we have to subtract from this? So I want to subtract some x. So minus x is equal to, result is minus 1. So this is the condition. Now let us take minus 5 by 7. So here is minus x is left. Now this minus 5 by 7, if you take this side, plus 5 by 7, because additive inverse. Now if you simplify, this denominator is 1, 7 is LCM. Okay, minus 7 plus 5 that I am taking. There is minus 2 by 7. So minus x value is minus 2 by 7. So cancel negative sign both sides. So x is equals to 2 by 7. So if you subtract 2 by 7 from minus 5 by 7, we'll get the minus 1. So this is the subtraction of rational numbers. So we can see the similar some properties also in this. So same way similar like addition, because in subtraction does not exist a commutative property. So some properties is not exist. So I'm not discussing all the properties. Now let us see multiplication of rational numbers. Multiplication of rational numbers. Okay, so let us see this multiplication of rational numbers. So how we need to multiply rational numbers? So I have seen previous addition of rational numbers and subtraction of rational numbers. Let us see this multiplication of rational numbers. So the rule is the product of two rational numbers of a by b and c by d. This simple formula or this rule: if a by b and c by d are two rational numbers, so multiplication of rational numbers is a by b into c by d. That is nothing but numerators you can multiply by, denominators also we can multiply. That's a into c by b into d. So this is simple rule. Let us see the examples and we'll see some properties also in multiplication. So for example, multiply minus 7 by 8 into 3 by 5. So we need to take numerators and denominators. So directly we'll multiply. That is minus 7 into 3 by and 8 into 5. Minus 21 by 8 5 so 40. Because minus 7 and plus 3 it is. So this is minus 7 into plus 3. So minus into plus is minus. So you know the rules, right? 4 rules. Plus into plus is equal to plus, and plus into minus is minus, and minus into plus is also minus, then minus into minus is only plus. Okay, these are the rules only we need to apply when you are multiplying the numbers and positive and negatives together. So we can do calculations or cancellations also in these sums. For example, we need to simplify minus 11 by 9 into minus 51 by 44. So this is the given question. So first we can write same step, minus 11 into minus 51 by 9 into 44. So instead of multiplying 11 into 51 by 9 into 44, if it is common divisors are there, you can cancel it. So I am cancelling here with 11 table, because 11 ones are and 11 fours are. Same number we should cancel numerator as well as denominator, any number. Same table only should apply. So 11 table I apply, 11 ones and 11 fours are 44. Now 51 and 9. So I'm going to use 3 table, because 3 are the divisors, 3 are the factors for both. Common factor. 3 is the common factor both, so I can apply 3 table. 3 3 is a 9, and same 3 table only for 51 also. That is 3 ones are 3 and 21 means 7. So 3 17s. Then the remaining you can write minus 1 into minus 17 by 3 into 4. After cancellations, the rest of things you can write. So minus into minus plus, 1 into 17 is 17 by 3 fours are 12. So 17 by 12 is the multiplication of minus 11 by 9 into minus 51 by 44. So this is the way we'll follow. So let us see some properties also in this multiplications. Properties of multiplication of rational numbers. Properties of multiplication of rational numbers. So as we discussed properties of addition of rational numbers, similarly we'll see some properties of multiplications of rational numbers also. So in multiplication also closure properties exist. First property is closure property. So closure property is same what we have seen additions. Here a by b and c by d. If two are rational numbers, then a by b into c by d is also rational number. A by b comma c by d are two rational numbers. Then a by b into c by d is also a rational number. And commutative law. So commutative law says this is if you take two same a by b and c by d are two rational numbers, then commutative law says a by b into c by d is also equals to c by d into a by b. So however you multiply, the result will be same. So that is called commutative law. Next let us see associative law. So in associative law is for three rational numbers, same like additions you have seen. In associative law, under multiplication of rational numbers, if a by b and c by d and e by f, okay, a by b comma c by d and e by f are any three rational numbers, then if there are any three rational numbers, then as associative law a by b into c by d, first two will multiply, then with result will multiply e by f. That answer is also equals to a by b into bracket of c by d into e by f. In second and third rational numbers will multiply, then the result will multiply first, even though you'll get the same answer. So that is nothing but associative law. Okay, in multiplication, the existence of multiplicative identity and multiplicative inverse. Let us see here some points. Existence of multiplicative identity. Multiplicative identity. The rational number 1 is the multiplicative identity. So in rational numbers 1, so actually additive identity is 0, but multiplicative identity is 1. So 1 is the multiplicative identity. That is a by b into 1 is also 1 into a by b, even though you'll get same a by b one. Okay, for example, if you take 2 by 3 is a rational number, you just multiply with 1. So you'll get same 2 by 3. Okay, 1 into 2 by 3 also will get same 2 by 3. That's why this 1 is the multiplicative identity. Now multiplicative inverse. multiplicative inverse. So inverse means here every non-zero. For example, if a by is one fraction, so what I should multiply to get multiplicative identity? So a by b into dash is equal to 1. That means nothing but b by a. So reciprocal. That is every non-zero rational number a by b as a multiplicative inverse, also called as reciprocal, that is b by a in the set of rational numbers. So reciprocal itself is a multiplicative inverse. Okay, example, for 2 by 3 multiplicative inverse is 3 by 2, because this result will be equal to multiplicative identity, that is 1, because 2 2 and 3 3 get cancelled, 1 will go. This reciprocal. So if minus 3 by 2, then minus 2 by 3 is a multiplicative identity because reciprocal of that. Okay, if we take 1 by 17, so 1 by 17 multiplicative inverse is 17 by 1, that is equal to 17 only. Okay, that means we just multiply 1 by 17 into 17, or else 17 into 1 by 17, you'll get only 1. That's what reciprocal of 17. So 1 by 17 is the multiplicative inverse. Then here some important notes. If you see, so 0 has no reciprocal, because 0 has no reciprocal. That's the important points. So I first need to remember this. Every number has reciprocal. 0 has no reciprocal, and reciprocal of 1 is 1, and reciprocal of minus 1 also minus 1 only. These both are same. Reciprocal of 1 is 1 itself, and reciprocal of minus 1 is also minus 1. That means the reciprocal of same number is itself is only 1 or minus 1. So in objective purpose, reciprocal of a number itself is equal means there is 1 and minus 1 only for 2. And fractions we can make, for example, a by b, we can write a by b whole to the power inverse also. There is also reciprocal, because b by a we can write as a by b whole to the whole inverse. So this is reciprocal of this, we can make in this way also. And reciprocal of any integer is nothing but 1 by a. So reciprocal of a is 1 by a. So b is 1 by b. So this is the way we can make. These are the properties of multiplication over addition, and we'll see some multiplication over addition, multiplication property of 0 also. Okay, these are the properties under multiplication. Now let us see the division of rational numbers. Fine, let us see division of rational numbers. So how to do division of rational numbers, we'll see now here. So division of rational numbers. So let me explain this, how we need to do divisions under rational numbers. So consider two rational numbers a by b and c by d. So let us take a by is one rational number and c by d is another rational number, but c by d is not equal to 0 because division, right? So denominator place should not be 0. Then we define a by b divided by is equal to c by d, because division, this is nothing but a by b into d by c. So multiplicative inverse we need to take here. That means the division when you write as into, then c by d becomes d by c. So reciprocal. Next fraction reciprocal you should take. Because directly division we can't do like natural numbers or some integers. Here we need to convert into multiplication. Then we have to do. So in order to divide a rational number a by b, another rational number c by d, we need to multiply a by b by multiplicative inverse of c by d. That is nothing but d by c. So when a by b is divided by c by d, then a by b is called dividend and c by d is called divisor, and the result of the division is called quotient. Okay, this is dividend and divisor. So we are applying. So a by b is called dividend and c by d is divisor. So divisions only we are converting as multiplications, and we can do this. So let us see example. For example, divide 11 by 24 by minus 5 by 8. So according to rule, what you should take first? 11 by 24 and divided by minus 5 by 8. Okay. So according to condition now, see here, a by b divided by c by d is equal to a by b. In the place of division, we'll keep into d by c, because it's a reciprocal, because divisions, if we convert it into numerator place, it will be reciprocal. The same will apply for this question also. That is 11 by 24 into symbol when you keep, this is 8 by minus 5. So 11 by 24 into 8 by minus 5 or minus 8 by 5, because denominators make it as positive always. Then normal multiplication we did previous topic. 11 into minus 8 by 24 into 5. If it is possible of cancellations, you can do it. So I can cut this both two table, because 8 and 2 are factors are 2. 24 and 8, 2 is a common factor. So 2 12s and 2 4s. Still 2 is a common factor. 2 6 are 2 2s are 4. Again 2 is a common factor. 2 3s are 2 1s are. So finally 11 into minus 1 by 3 into 5. That is minus 11 by 3 5 is a 15. Right? So minus 11 by 15 is the answer of 11 by 24 by minus 5 by 8. So one more example I'll take, you'll get some clear idea. Example, divide minus 9 by 40 by minus 3 by 8. So divide this. So as per the rules, minus 9 by 40 divided by minus 3 by 8. So we need to write as minus 9 by 40 into minus 3 by 8 is reciprocal is minus 8 by 3. Okay, make it as positive denominator. Then minus 9 into 8 by 40 into 3. We can cancel. Yeah, common divisors, common factors are there, you can cancel it. 4 table, 4 ones are 4 2s 8, because 4 is the common factor for 4 and 8. Fine. Next to 9 3. 3 is a common factor for this. 3 ones are 3, and 3 3 is a 9. So remaining is minus 3 into 2 is on numerator place, 1 into 1 denominator place. So minus 3 into 6 is minus 6 by 1. That is nothing but minus 6. Right? So this is the divisions we can do on rational numbers. So divisions also we have some properties. I'll explain you some properties of division of rational numbers. So when you come to the properties of division of rational numbers, properties of division of rational numbers. Fine. So there are some three properties I'll explain here. First property under division of rational number, that is closure property. So this closure property says if a by b and c by d are any two rational numbers, then a by b divided by c by d also rational number. Same, there is closure. If a by b and c by d are any two rational numbers, then a by b divided by c by d is also rational number. Right? Now just to see the, okay, if you do division, you automatically will get the rational number as answer. So it's a closure property, it exists. Second is, for any rational number a by b, we have, for any rational number a by b, we have a by b divided by 1 is also a by b. So if you do division with 1, we'll get the same number. Fine, it's very clear. That means, for example, if you take 2 by 3 divided by 1, again you'll get 2 by 3 only. Or minus 5 by 6 divided by 1. So we'll get again minus 5 by 6. Okay, this is the second property. So third property under division, for any non-zero rational number, a by b, if a by is non-zero rational number, then we have a by b divided by a by b is equal to 1, because that number divided by same fraction if you take, we'll get the 1. This is property 3. So if I want to see example for this third property, now 5 by 6 divided by 5 by 6, this result should come 1. So you can check it, 5 by 6, if you keep division place into means is 6 by 5. Okay, that is, we can do night multiplication. 5 6 are 5 into 6 by 6 into 5, 30 by 30. 30 by 30 is 1, because 30 table 1 is. So not only positive, you can take negatives also. For example, minus 7 by 9 divided by minus 7 by 9. So you can write minus 7 by 9 into minus 9 by 7. So 7 7 cancel, 9 9 cancel here. Minus 1 into minus 1 is equal to plus 1. So for any non-zero rational number, because a by b, it should be non-zero. Because 0 by 0 is not 1, right? That's what. That's an important note. Because 0 by 0, again it is 0 only. So this is not equal to 1. 0 by 0, because same number means it's not equal to 1. So we'll use non-zero of a by b. So these are the properties from the divisions we can apply. Now I will explain you how to find the rational numbers between two given rational numbers. Now this topic, method of finding a rational number. Rational number between two given rational numbers. So I'm taking some color. Method of finding a rational number between two given rational numbers. So if they'll give any two rational numbers, how we can find out some more rational numbers between them is the topic here now. Consider two rational numbers a by b and c by d. Okay, I'm taking two rational numbers a by b and c by d. Here a by b is lesser than c by d you take. Then the rational number between them, between these two rational number if you want. So rational number between these two means a by b and c by d is half of the. So half into a by b plus c by d. So meaning of this is the both rational numbers will add and will multiply with 1 by 2. Then we'll get exactly middle number of the two given rational numbers. Okay, I'll give an example, it will be clear for you. Example, find a rational number between 1 by 4 and 1 by 3. Find a rational number between 1 by 4 and 1 by 3. So between 1 by 4, 1 by 3 we need to find out a rational number. So what we want to do according to formula? So we have, so just take 1 by 2 into, so bracket also denotes into symbol, 1 by 2 into 1 by 4 plus 1 by 3. So both rational numbers you need to add, that is 1 by 2 into, so within the bracket we'll add this first, 1 by 4 plus 1 by 3. So 4 comma 3 LCM is 12. 4 comma LCM is 12 as we discussed previous. 4 table 12 is 3 are 3 into 1 is 3. In 3 table 12 4 are 4 into 1 is 4 because numerator. Now 1 by 2 into 7 by 12. Again like normal multiplication, 1 into 7 by 2 into 12, that is 7 by 24. So 7 by 24 is the number between 1 by 4 and 1 by 3. So for example, except not only 2, if they asked more than two numbers, more than one number, if they ask between two rational numbers, how we need to find out? So directly I'll tell you one direct shortcut method. This first method is only finding exactly one number, finding exactly one number between two rational numbers. Now apart from that, for example, finding a method of large number of rational numbers between two given numbers. So how to find out? So example I'll explain. Find 4 rational numbers between, so 4 we need to find out, between 1 by 2 and 1 by 3. So between these two I need to find out 4 rational numbers. So for this, you should take 1 by 2 and 1 by 3 as this. Once you check this denominators, here denominator is 2, here is 3. If you can make the denominators are same, then by observing numerator we can see the middle numbers. Now we have 2 3, so 2 3 LCM is 6, so that we need to make it as 6. So that's why this multiply with 3 by 3 and this multiply with 2 by 2, because denominators must be same. At the same time, same number should multiply for numerator also. Then that is 3 by 6. Now this is 2 by 6. So 3 by 6 and 2 by 6, between nothing is there, because we can't make it more, because after 2 exactly 3 will come. Now increase the denominator, so take extra one more number. Now into, again take 3 by 3 and 3 by 3, same number, just multiply both sides, because we need to increase the denominator. Then as per the numerator we can check. Then this is 9 by 18, 2 3 is 6 by 18. So 6 by 18, 9 by 18. So we can, between them hardly 7 by 18 and 8 by 18 only coming. Only 2 are there. But we need 4 rational numbers, right? Okay. Between 6 by 18, 9 by 18, only 7 by 18, 8 by 18. So we need to increase some more denominator. That means just multiply it again, 2 by 2 into 2 by 2. Because same number should multiply. Then only denominator will come same. Numerator will be changes. That is 9 2 is 18 by 36, and this 6 2 is 12 by 36. Then in between we can write, so between this both 12 by 36, no, so 13 by 36, 14 by 36, 15 by 36 and 16 by 36, even 17 by 36 also. So how many are that many can write? That's only 4 rational numbers. So these 4 we can take are the between the two given. So between 1 by 2 and 1 by 3. Just you need to extend this. So how many numbers there are, that many numbers we can make it. So this is finding a large number of rational numbers between two given rational numbers. I'll take one more question. Okay, for example, find 10 rational numbers between -3 and -1. Find 10 rational numbers between -3 and -1. So here there is no denominator. Yeah, 10 we need to find out. See the solution. -3 and -1. So -3 is lesser than -1. Just to take divide by 1 by 1. Now denominator is the same, but hardly we can take -2 only between. So try to increase the denominator. If I multiply by 5 by 5 and 5 by 5, so how much you'll get? 3 5 is 15. Minus 15 by 5, and this is -5 by 5. Yeah, 10 will come, right? So -6 by 5, -7 by 5, up to -14. So let us check where 10 will come or not in between. Between these two, -6 by 5, -7 by 5, -8 by 5, -9 by 5, -10 by 5, -11 by 5, minus 12 by 5 minus 13 by 5 minus 14 by 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 are there. These all together only 9. But we need 10. So that we need to increase some more. That means here 5, no? So extra into 2 by 2 we do it. Into 2 by 2. Now that is minus 30 by 10 and minus 10 by 10. So there are minus 11 by 10, minus 12 by 10. We can take many. So between these both, so we can take many. That means minus 29 by 10, minus 28 by 10, minus 27 by 10, minus 26 by 10. So on up to we can write minus 9 by 10 also. So not only 10, we'll get more than 10. So this is the way we can write rational numbers between any integers, whole numbers, natural numbers, even rational numbers also. So how many you want, that many we can make it. Fine. So these are the properties of divisions. At the same time, this is the condition finding rational numbers between the two given rational numbers. So fine, I hope you understood well this topic. And for the same topic, if you required the material, so you can go to this website. In this website, ICSE syllabus class 8 information is there, and subject wise, I mean topic wise, every chapter wise, there are model papers and question bank test papers are available in this website. You can go through this and subscribe this channel. We'll upload only the educational videos, completely ICSE, SSC and intermediate, including IIT, JEE. All the information is completely free. You can subscribe the channel as well as you can go to this website for further more details. Fine, I hope you understood well. Thank you for watching this video.